Morning. Right, I wanted to intro to a new project I'm doing. Only literally just started it today, and what it is a weather balloon project. Never done one of these before, so this will be very interesting. And there's quite a few challenges to get over as well. I've drawn a very terrible drawing of the journey of obviously a weather balloon, if most people do know what they are. But obviously, up, down, back, kind of the simplicity of point of view of it. What the aim of this is want to start off trying to learn how to get things up really high, and also return some footage as it goes on. Because I think I've seen a lot of videos on YouTube for it, but I would like to see it for myself, what it looks like up there, and then how high we can get really. And maybe explore putting other things up in space, maybe a little glider that can autonomously fly back. But first of all, I've got to crack the idea of actually getting something up there and surviving, because after a bit of research I found that it's pretty cold when you get up to about 100,000 feet. It's about minus 50, 60 degrees, and it progressively gets colder until the point that it gets really strangely warmer, I think. So obviously one of the first challenges is going to be temperature. Not most electronics don't like that sort of temperature. Some can go down to minus 30, minus 40, but you don't really want to be hitting going to those limits, or you could risk failure, premature failure. You know, if there's something wrong in manufacturing, because you're not buying high grade items. So excuse me. The other one is finding the damn thing after it's come back. As it gets higher, sometimes you can get different wind speeds as you go through all the different layers of the atmosphere. More turbulent as at low level, and it gets smoother and smoother, but it can become faster as you go up through the atmosphere. So if it spends ages getting up because you've done a calculation wrong, you could find it's drifting for quite a long time before it comes down. So I think one of the things to obviously try and do in this project is to make it so we can prematurely disconnect from the balloon and come down, just in case it starts drifting out, because I'm in the UK, so we haven't got a heap load of landmass around us, and I don't want to be seeing it then in the ocean, because I would quite like this back to do, to improve on it next time. The other challenges are obviously my inability to not cough while recording. That's a pretty severe one. Sorry about that. So you've got temperatures, communication, return back. Obviously, it's got to be done off a parachute, and this is my terrible drawing of a parachute. Looks like an umbrella. We're going to obviously need to find one, find the masses, and then work out the best way to attach it. Why it's not a problem. Will be quite interesting. Communication is going to be interesting as well, because obviously at this distance up we're talking quite a number of miles. I've done stuff with drones before, but doing long range stuff always for me required high powered transmissions or really low frequencies. I think in the UK there's quite strict rules on this, using certain radio frequencies, so that would be an interesting one to circumvent. But the idea would be to be able to track what's going on inside and some information around what's going outside, and then track where it is, in time and altitude across the whole journey, because I feel like it's important. It's quite very interesting to see as well. Plus, when you're sitting on the ground staring at the screen, you'll actually have an update of something that's going on instead of has it landed yet? And then obviously I hope it doesn't land in water, so maybe plan something around that allows it to float. What's the other things I want to talk about? When you have these videos and you go, oh yeah, I'll plan it out, that's fine. So one of the things I want to probably talk about first is what we can use as the brains for this. I was probably going to use, I think an Arduino is a pretty good sound choice. There are many flavors of Arduinos. I've used the Arduino 328P. It's quite a very cheap, common one. And I've also used the Teensy 3.2 series. They both have advantages and disadvantages. Obviously the 328P, I think I might find one and show you next time, is very low powered, very cheap, but it does have limited functionality, so it's only I think 8 or 16 megahertz, and then the 3.2 Teensy is more of a fuller ARM processor, but it's like 96 megahertz and has way more IOs, but requires more power, has a custom library, so it's not 100% vanilla Android. What maybe is not always ideal if you want to find a library to use, or etc. But the idea is I'll cover the challenges that are obviously going to come up in this. Thank you, Pump. And in across a few videos, probably going to be about 8 to 10, and then obviously go through the building of this as we go along, and work things that I work out along the way or fail at, and hopefully we get to a point where this goes up and comes down. Oh, another thing to note, you need CAA clearance to do this, so that'll be a learning experience in itself. Obviously going through the paperwork, the rules, etc. I do have some knowledge of aircraft and flying, so I am aware of the stuff around me, so I know that could be an interesting challenge to get around. But for the first go, I think over 100,000 feet, I'd be pretty happy, and if we can get it back, be even happier, because obviously I'm sticking a camera on this, so I can't beam the footage back, especially over that long distance. Would be quite tricky, let's say. But yeah, this is what this project's going to be about. So I'll next video hopefully do in a week's time. Probably try and tackle the communication aspect, as I think that would be quite a challenge on, or the temperature. We'll see how the week goes. But that's me anyway. Thank you very much.